So this is an updated video just to show the progress of my camping with solar relay controller. Essentially the whole idea of this project is to enable me to connect up two batteries to the system along with a CTEK 250S dual DC-DC converter for the purpose of charging the batteries from solar panels, and as well as provide a power source to devices such as refrigerators, lighting and so forth. So the whole idea here is that rather than me having to monitor the state of a battery, I can let this take care of it for me automatically and have it automatically switch between charging and source as I see fit. The whole idea being to maximize the lifetime of the battery by keeping it above 50% discharge and some other factors. So at this point I've wired up the Arduino. There's no software on it yet, haven't written that. I've completed the prototype. It's quite a mess, but that's purely because of the additional wiring that I had to do to interconnect everything. I've got my three relays, so the first two on the left represent those that will be connected to battery 1 and battery 2, and the one on the right represents an isolation relay. So the idea will be that when the system powers up, initially that third relay will energize to isolate the batteries from both the CTEK charger as well as ensuring that no power source is provided to the devices at the campsite. And then the system will switch over. It'll de-energize the isolation relay, and then the other two relays will control whether the power source is connected to the charger or to the refrigerators and so forth. So what I'm aiming to do is have a default startup status of isolation, and when it goes out of isolation, the default status would be to be providing power source to all devices from both batteries. So the way I'll know whether this is working or not is on this board there are two LEDs. The one on the left represents battery 1 and the one on the right represents battery 2. And when it's isolated, these two lights will flash alternatively blue. When an LED is green, it'll be indicating that that particular battery is being used to provide a power source, and when it's red, that will indicate that it's being charged by a charger. I can't show that part of it yet because I haven't wired up the actual car batteries, but we'll at least see the relays change state, and we'll see the lights change status. Now, because I've only got one pair of hands, I've got Philip here to help me control the system in terms of powering it up and changing the state and so forth, just to emulate what the software is going to do. So I'll be talking to him through what I want him to do. So thanks, Phil. So to start off with, the three cables over here, the orange, white and yellow, they're currently not connected to either ground or a positive rail. So that's just emulating the Arduino having three digital outputs pretty much in a floating state. So I just want to show that at least when we first power it up, the third relay does energize to show that it's isolated and that the lights flash blue. So Phil, plug her in. Now we heard a relay click and we've seen the blue LEDs begin to flash. So the Arduino itself at the moment is only really being used to provide a 5-volt rail to the circuit that I've created, and the 12 volts that's energizing the relays is coming from just a little battery pack here. So I've actually got 12 volts and 5 volts going through this system. Just to show that relay, Phil, if you can just disconnect the power and reconnect. So we can see those top connections changing state just a couple more times. Yep. Alright, so we can see here that it is energizing the battery, the relay. And just to show that that is the default state, Phil, if you can just move the white wire, which represents the isolation relay, just change that into the high line, and we'll notice that there's no change of state of the relay, and the LEDs are still flashing blue. So that's what I'll be programming the Arduino to do. It'll be set up to send out a high state, but I wanted the initial power up to also isolate, ensure that the isolation relay is energized. So that's working fine. Now if you can just change it down to the ground level. So that will essentially be me programming the Arduino to turn the isolation relay off, which means that power would essentially be going through those other two relays. And we can see here that the two LEDs are now green. So that's indicating that both batteries are being used as a power source. Now again, the yellow and orange wires, they represent the floating state. And by default, they would be at a ground level. So Phil, if you want to move both of those to the ground line, both of them, to the orange one as well. So there was no change of state of the relays, and the LEDs have remained green. Just to show now that we can change those at any time to represent either a power source or charging. If you'd like to move that one to the high line. So we can see there that the second battery, or the relay associated with the second battery, has changed state, and that's going to indicate that that battery is now being charged, and hence the LED has gone red. Just to show that that second relay is the one that's energizing. Phil, if you can just change the yellow wire to go from high to low, and back again, and one more time. Okay, so that's showing clearly that the second relay is changing state as that digital output does. So now we can do the same thing with the third one. So if you'd like to change it from a low to a high, we can see it's now gone to a charging state. And again, if you can just change the state, and again, and there again we can see that that relay is also following suit. Now the system's quite happy for both to be charging or both to be used as a power source. So Phil, if you can just change both the orange and yellow wire back to a low state, we'll see that both LEDs go green, and back again. And now move the white one back from a low to a high to indicate isolation, and we can see there that the blue LEDs are flashing again. So all I've got left now to connect up is an LCD display to show me the actual status of what's going on, and I've also got to wire up a switch and possibly some other circuitry to prevent debounce, just so I can manually isolate and de-isolate while out in the field. And that's current progress. Thank you.